Hello, I'm Phillip McKay.
I'm Austin Anspaugh.
We're doing logic for a control circuit. This is our expression we got given to us. It was A and B and C, or A and not B and C, or A, B and not C. For our simplified expression, we ended up with AB or AC. Our truth table, we have A, C gives you the output, A, B, not C gives you the output, and then A, B, and C give you output. For our K mapping, we have the grouped here and the group here going over to A and B, and then going up to C.
So as we come looking over here, when we get to the actual board itself, since we do have, as we referred to earlier, you do have an A and a B. You also have an OR, and then you also have another A and a C. So in this situation, for the two AND gates, we actually got really lucky and we're working with a dual input. So that's why you don't see three different chips, and that's why you only see one AND gate. And basically what you're looking at here is we have our pin 1 and pin 2. Those are going to be wired up into the switches up here. So our 0 is our A, our 1 is our B, and our 2 is our C. Since we do have an OR gate here, what we need to do in order to make this LED light here, which is what the output of the OR gate is going to, in order to make that illuminate and to tie everything in together, we have to take all of our outputs from this AND gate, and instead of running those to the LED, we run those into the input of this OR. And then the output is what's going into that LED. So when we turn it on, obviously we don't have anything going on here because there's no switches flipped. But looking back, yes, going back into account with the truth table, and if everything checks out, and if we did everything right in terms of simplifying it and hooking everything up correctly, what we should get is we should get an output if we have A and B and C on. So let's see if that happens. So if we turn on A, we turn on B, we turn on C, we are good to go. If we look back again, and this time, if we have A, not B and C, we should have the same results. So if we take our B, which is our number 1 again, if we go ahead and turn that off, we should still have illumination there, and we do. And then finally, we can do the same thing, except this time we're gonna have A and B and not C, and we should get the same result. So if we turn B back on, and then we turn C off, we should have an LED, and in this situation we do. So that way we know for sure that that checks out. But what we also have to do is we also have to make sure that everything else lines up. So in this case, if we just have, let's say, A by itself, there shouldn't be anything, and there's not. If we have just B and C and not A, we shouldn't have anything, and we don't. And then also, if we just have just B, we shouldn't have anything. If we have just C, we shouldn't have anything, and we don't. And then obviously, as you saw earlier, with nothing actuated, you won't have anything either. So
For troubleshooting, we had an issue. We came in where the LED was on and no switches were on. We noticed the OR gate here was elevated a little bit, and the chip actually was bent, the one for the power here. And once we fixed that, we had a working circuit again. Just want to say thank you. This is Phillip McKay.
Austin Anspaugh.
Have a good one.